Hi, this is Mr. Barron. I just wanted to review some measurement techniques that we'll need in this class to be successful. First off is precision. Precision is how close measurements are to one another. So if I kept making measurements on an electronic balance of the same object and they kept coming out exactly the same, that would be called precise. If those measurements were coming all over the place, then they'd be called not precise. So precision is how close measurements are to one another. So you can see if each of these darts represented a measurement, these are all close together, these are all over the place, you can see what's precise and what's not precise. Accuracy is how close measurements are to the actual value. So the actual value would be, in this case, the dart metaphor, right on target, meaning it's really close to this actual value. And actual value means it's its true value. Now, do we know whether something is exactly its true value? Not necessarily, but we know whether we're close or not. So all of these darts are representing measurements made all close to the actual value for whatever we're trying to measure. These would be not accurate. One of the things that you can notice is that you can be precise but not accurate. But if all your measurements are accurate, you're accurate and you're precise. So, precision of measurements. Which graduated cylinder is more precise and would yield a better measurement for a penny being measured as far as volume? One on the left, because you definitely have a greater, you have a finer detail in terms of what's being measured. An example measurement, you have more significant figures with the one on the left, 4.20. An example measurement, the one on the right, 2.5. So the uncertainty is lower for the graduated cylinder on the left, and that would be this value right here, than the one on the right. So if you have a penny with a volume of 0.1 milliliters, the cylinder on the left is the only one that can measure it because it is more precise. So the lower your uncertainty, the higher your precision. On the right, you got a higher uncertainty, low precision. So which of the following dartboards represents a random error? Where you're just, you got something that's randomly going wrong, like your partner spills the water that you're trying to measure, or you accidentally forget to zero your balance. C would represent random errors. Systematic errors are where you're missing the target, but you're consistent. So that would be precise measurements, but they're all being caused to be off. An example of this would be if you have a balance and you forgot to hit 0, and before you put all of your mass measurements on the balance, it was reading negative 1.5. So all of your mass measurements are going to be short 1.5 grams. So this would be an example of it. So systematic errors are due to causes that are consistent throughout an experiment. Random errors are due to random fluctuations in how the data is collected and identified. I would actually go back and pause it right now and write that down. Now, precision in measurements. Whenever you make a mistake in a measurement, an error in a measurement, when those independent random errors in measurements occur, their effect, how big those errors get, are magnified when you do a calculation. So if you have a mass measurement error because you forgot to zero it before you put it on, your density calculation is going to be even bigger off than your original mass measurement because you have to divide it by volume. Errors propagate throughout labs. Another thing that we need to pay attention to is that glass or water is attracted more to the glass than itself. So when you have a glass burette or a graduated cylinder, you get this thing called a meniscus. We always measure at the bottom of the meniscus. One of the ways that we need to do it is by looking straight on. This is the correct volume. You have to look at it straight on like this, not from down below or from up above. That's called parallax error. In terms of incorrect viewing, that's an example of it again. Correct viewing straight on. If you have any other questions, please let me know.